Hey, Katie here. I am the project manager of CNS2 Class 18. Today's project is the Vsauce video, How the Earth Moves. My group will be presenting. We have Connor here, Jeannie, and Alexis. We'll be doing a Kahoot game based on the time zones. So everybody have your Kahoots ready, put in the pin, and we'll be starting the game. Just let me know. Ready? Okay, we have both on. Go ahead. You need to do stance. Okay, big breath. Okay. I don't know. Who's still trying to get in? Okay.
Is it on your phone?
You can do it on your phone, you can do it on the computer,
KH,
all that stuff.
Kahoot.it.
Yes. I'll have 10 seconds and then we'll start.
So Kahoot.it?
Yes. Snorlax. Nice. B. Word waffles. Love it. Okay, 10, 9, 8,
Wait.
7, 6, 5, 4, 3, 2, 1. All right, let's start. You can, yeah. So, are you ready? How did people tell time? They told time by using a cat, the sun, they just knew, or they used the lamp to tell the time.
I have to answer it too.
You don't have to say it. All right.
3, 2, 1.
And it was the sun. Nice. All of you got it right. So the way people told time was they used the sun, right? The way they would find out when noon was by figuring out like noon was basically when the sun was at its highest point in the sky. That's when people found out when it was noon, and people could go to lunch or do whatever their thing was. Next question. Connor.
Hey everyone, so the next question, what is the likely origin of the first sundial? So we've got the Roman Empire, we've got ancient Egypt, we've also got Galileo and Leonardo da Vinci. Where did the first sundials come from? And it's ancient Egypt! Haha, some people chose the Roman Empire. Wrong. No, actually, ancient Egypt. So it goes back to the video we saw yesterday. Think about how the Egyptians praised they worshipped the sun, right? And so people had a good amount of time on their hand, and eventually they figured out how to track the sun, and they came up with the sundial. But the earliest origin that we've got of sundials are from 1500 BC, around the time of the Egyptians. So, yeah. All right. So the next question: why do clocks turn clockwise? Clocks have always been built to turn clockwise. Right is always stronger than left. International Organization for Standardization agreed upon it. Or sundials. Oh my God! Okay, well. So most of you got the right answer. It's sundials. So it goes back to the Egyptians. Back in the day, they didn't have any gears or they didn't have any craftsmen to do this sort of work. So what they did is they basically used the sundial, right? So think about how the sun rises. It rises in the east and it sets in the west. When you got a sundial, you always have to point it to the north, so that wherever the sun is, it will cast a shadow, and the shadow will move according to the sun, right? So that's how sundials basically work. Yeah. The next up is Jeannie.
Okay, next question. Is there a purpose for different time zones? Yes, maybe, or no? Yes, about 10 seconds. So it looks like everyone got it right. So the main purpose of different time zones is that so that if it's noon here, it doesn't mean it's noon in like China. So everyone has their own like noons basically, and you cannot have like different noons on every single location. That means if it's noon here in Seattle, it's also like 12 in Spokane, just so it's easier to trade with them because they're close by. The next question. True or false? Are time zones separated by longitude? Actually true, because longitude is vertical, it cuts the earth vertically, so it's basically a pie. So Washington, California, so that's like a pie of a longitude. That area will have one time zone at each and every one around there. Next question. And which way are latitude? Is it horizontal, diagonal, vertical, or parallel? Ooh, it's actually horizontal. Quite a lot of you guys got it wrong. Like, if you if you watch the video, a great way of thinking about it is what Michael said is flatitude is latitude.
Yeah.
Which is flat, like horizontal.
What is the technical term for noon for you? Sidereal apparent time, Mahana noon, local apparent solar noon, or Lahihi noon? Right, most of
It's
you
fine.
have gotten it right. Okay, local apparent solar noon is happens when the subsolar point falls somewhere on your meridian. How could a person tell what time it was if every meridian had its own time? They didn't, they did, or their biological clock determined it. Okay, so most of you thought that the clock did it, but they actually don't, because if every person had, because they each have their own meridian that they sit on, if each meridian had its own time, then the person next to you would see different shadows than you. So we established time zones.
So twice a year, the subsolar point crosses where in the U.S.? Does it cross in Texas, New Mexico, Hawaii, or Narnia? It's Narnia, guys.
It's always great.
Oh shit.
What's it?
Nice. Nice. Okay. Basically, when the subsolar point happens, if you're ever at the equator, the sun is above you. It's not like here in Seattle where the sun's like kind of like there, you know. So when this happens, all the shadows start to go down. When you're standing, there's no shadow standing behind you, no shadow standing beside, like in front of you. None of that is happening. The shadow's straight down because the sun is pointing vertically on the earth, parallel onto the Earth's surface. Next question. So what did it call the subsolar point in Hawaii? Did it call it Hainanu, Lahainanu, Lahydrinu, or Hainu?
I'm confused.
I knew.
That's my last one.
Why is this Arkansas, but not Arkansas?
So yeah, fun fact. I was in Hawaii when I was like in middle school, and it was like around springtime. It was like I was there at spring break, and the solar noon happened. And I remember I was standing there. I would look at like a pole, and there's just like no shadow there. It just looked so unreal. It was like really weird. So like there's like literally no shadows, but you can really kind of see your shadow if you're like looking straight down. So it's really strange, but it was a really cool experience. And so thank you guys for playing. Oh, who's third place?
Hey.
Red.
Congrats, Red.
Guys. Okay.
Big
Big Red. Who's Big Red?
Nice.
Figures.
And